Hello, welcome to our first lesson on trigonometry. Okay, so trigonometry is the branch of mathematics that studies the relationship between sides and angles of triangles. So some of you are probably asking, why are we taking trigonometry and geometry? Well, because we have a right triangle. So trigonometry, the start of it, we're going to be looking at sine, cosine, and tangent. Okay, so the three trigonometric functions that we're going to look at are sine, cosine, and tangent. And we're going to look at these all in a relationship with a right triangle. So again, we have to have a right triangle, and we're doing right triangle trigonometry right now. And the key piece to this entire topic is knowing what angle you're focused on. Okay? So when we are focused on this angle here, X, we have the three sides of the triangle kind of positioned around us. Okay. From this angle X, there are two sides that meet to make that angle. Now, we're not going to be using the right angle here. Okay, the right angle, we're really going to focus on this acute angle down here or this acute angle up top here. Okay, but if this is the one we're focused on, the side that touches that angle, that's not the hypotenuse, is always called your adjacent side. ADJACENT, adjacent. The side opposite your right angle, we all know where the hypotenuse. That's usually our C if we're talking about the Pythagorean theorem. Okay? But from our angle, if you're not the hypotenuse or the adjacent side, then you're labeled the opposite side. Opposite. So meaning if I'm standing here, if I'm a person standing at this angle, okay, I'm touching these two sides. The side opposite me has a length of 3. We're going to be able to find the measure of this angle based on these side lengths, 3, 4, and 5. Okay. But these O's, A's, and H's are the O's, A's, and H's here in this little acronym. So SOHCAHTOA stands for sine, cosine, and tangent. Sine of the angle we're focused on, so again, this angle X here, equals the opposite side over the hypotenuse, meaning 3 over 4. So we're looking at ratios here. So the O, so, S-O-H, CA, C-A-H, TOA, T-O-A, is an acronym to remember that sine is the relationship between the opposite to the hypotenuse of a triangle, the side opposite to the hypotenuse. Cosine is the adjacent side to the hypotenuse. So it's a ratio of the adjacent side to the hypotenuse. Tangent is the opposite side over the adjacent side. So looking at two examples here, actually, I'm not going to look at these right now. I'm going to come back to this a different day or on a remote Wednesday. What I'd like to do is jump over into actual notes 7.02. So again, this is a trig cheat sheet to kind of just discuss our main topic of trigonometry.
Good afternoon, may I have your attention, please?
So we're going to start here on note 702. So trigonometric ratios are used to find the sides and angles in right triangles. So again, it must be a right triangle. That's the only way we have a hypotenuse. Okay? And how the little formula goes is you have a trig function, meaning sine, cosine, or tangent. The angle measure is the side over a side. Right? So there's 3 trig functions: sine, cosine, and tangent. And the acronym reads SO, S-O, H. And I like to write it as like a little fraction like that. So, Ka, C-A-H, and Toa, T-O-A. So, Ka, Toa. And how that works itself out is it looks something like this. Now, I'm going to actually fill in the ratios as I go along here in this picture. So again, we have to first decide what angle are we focused on. And this little symbol here is a circle with a loop through the middle. That's the symbol, it's a Greek symbol called theta. That's going to be our angle measure here. I'm going to replace it with an x for right now. So that theta, just an introduction. We're going to really try to talk about angle x. Okay. With that, we need to first decide the opposite side, the adjacent side, and the hypotenuse of this triangle. So in this picture, since this is my right angle, 17 is always your hypotenuse, or the H measurement. So wherever we have an H, we're going to be putting in a 17 in a second. This angle X touches the side of 15, so that's called the adjacent side. So things that are adjacent to each other are next to each other. So this side of 15 is next to the angle X. It attaches to it. So the adjacent side, wherever we see an A in this acronym, so katoa, right, we put that 15 in. And if that's the adjacent and that's the hypotenuse, our opposite side is the 8. So wherever you see an O, we're going to put the 8. Okay? So sine, cosine, and tangent are three separate ratios. And that's kind of how this is set up down here as well for us. So sine, we abbreviate sin, as I just kind of made my I into the M. Sorry about that. Sin. And the reason we abbreviate sin is because on your calculator, there's three buttons: sin, cos, tan. Okay? So that's the abbreviation for sine, cosine, and tangent. Oh man, I forgot something really important about our calculators. Before we even go to the calculator, what I'd like you to do is go to your calculator, press the mode button right here, and we need to change from radian measure to degree measure. And I've tried to mention this in class over the last week just to get you ready for it. But degrees is what we're measuring our angles in. A radian is a measure to tell me how big this angle is open. This could be 1 radian measure from here to here as an angle. We don't measure in radians yet, we measure in degrees. So we have to make sure our calculator is set to degree mode. So we just arrow down and over, hit enter once, and now we have everything in degree mode. And actually, if you have a color screen calculator, it'll tell you degree right up at the top. Those are your mode settings up top. So sine of my angle, I'm going to put in that theta symbol. So we have a trig function, which is sine, cosine, or tangent. The angle measure, which is what we're looking for, equals the opposite side over the hypotenuse. So it equals a ratio. Okay? I'm going to flip back to that cheat sheet page where it's written out here 3 times over. Sine of the angle equals the opposite over the hypotenuse. So the opposite side is 8 and the hypotenuse is 17. So sin of angle theta is 8/17. And that's it. We're setting it equal to a ratio for right now. Okay. Cosine of that angle, okay, cos, abbreviated COS, of angle theta is always the adjacent side over the hypotenuse. A over H, adjacent over hypotenuse. So looking at the 3 measurements, the adjacent measure is 15 and the hypotenuse is 17. So cosine of theta is 15 over 17. And tangent, opposite, adjacent, tangent. The tangent measurement goes like this. Tan of our angle theta equals the opposite over the adjacent. So it's the OPP over the ADJ. So tan theta is going to equal, opposite is my 8 over adjacent is my 15. So that's just setting up the ratios, and that's what we're going to practice here in exercise 1. Then on the next page, we're actually going to use those ratios to do some cross products. So just notice when I say cross products, remember we can put tan theta over 1 and cross multiply here. And we're going to end up solving for that angle measure. So again, this is just the setup of the ratios to understand the process. Then we're going to go in and we're going to solve. I have 2 pictures here that are the exact same for exercise 1, and that's because here we focus on angle X. Here we're going to focus on angle Z, tan Z, cos Z, sine Z. So label the opposite adjacent hypotenuse for each, then write the ratio. So again, sine, cosine, tangent, we're going to have up top. Sine of X. So let's focus on angle X to begin with. Okay, so that's where we always start, is what angle are we talking about? Because it could be X or it could be Z. Okay, and we're going to look at part B to that picture in a second. But angle X, we know the 40 is the hypotenuse, so we're going to identify that. From X, this side, 24 touches it, so that's our adjacent side. And from X, the third measure is the opposite measurement. So sine of X equals the opposite over the hypotenuse, OH. So sine is opposite over hypotenuse. So the opposite side measure is 32. The hypotenuse measurement is 40. That's all I'm asking for. Cosine X is half the AH. So the adjacent side is 24. The hypotenuse is 40. Tan is TOA. The opposite side is the 32. The adjacent side is the 24. So again, we're just at the identification phase. Now that's going to all change when we focus on angle Z. So part B here, these are all focused over onto this diagram. Okay? So when we focus on angle Z, what changes? Well, the hypotenuse is still 40. But now 32 isn't the opposite side anymore. That's touching angle Z. So since I'm focused on angle Z, that's now my adjacent side. And this is my opposite. So here we have tan Z, cos Z, sine Z. So tangent of angle Z is the opposite over the adjacent is 24 over 32. Cosine is the adjacent over hypotenuse. So cosine is the adjacent 32. The hypotenuse is 40. And sine Z is the opposite over the hypotenuse is 24 over 40. Now something I'm going to point out here is that 2 of those ended up being equivalent ratios. Okay? See 32 over 40 here and 32 over 40? Aren't those both equal to cos Z and sine X? That's a little rule we're going to talk about later, is that cos from one angle equals sine from that other angle X. Okay? The cosine of one thing equals sine of the other, because those ratios are equivalent. Same thing, vice versa, with cos X is 24 over 40, sine Z is 24 over 40. So sine from Z equals cosine of X, because your opposite and your adjacent just kind of flip-flop depending on which angle you're focused on. So that little idea is going to be important in a few minutes. I'm sorry, in a couple different lessons from now. But that's something I'm just noticing to point out here. Parts C and D, I'm going to skip for now, and I'm going to move down to exercise 2. What other information do we need to find each ratio? So sine, cosine, tangent, and again, I'm going to write my acronym. So, SOH, CA, CAH, TOA, TO over A. SOHCAHTOA. I don't have the H measurement. Okay, I don't know what my hypotenuse is, but it is a right triangle. So first thing we're going to do, this got bumped to the wrong page, is Pythagorean theorem. 8 squared plus 15 squared equals my hypotenuse, C squared. 64 plus 225 is 289 is C squared. And I just happen to know the square root of 289 is 17. So our hypotenuse here is going to be 17. So that's my HYP. Now if I focus on angle A, for sine A, cos A, tan A, when we focus on angle A, 15 is my adjacent side, and 8 is my opposite. So focused on angle A, opposite, adjacent, hypotenuse, we have opposite over hypotenuse would be 8 over 17. Cosine is adjacent over hypotenuse is going to be 15 over 17. And tangent is opposite over adjacent is 8 over 15. However, that changes when we focus on a different angle. So sine from angle B, when I'm focused on angle B, this isn't my adjacent side anymore. This is my opposite side. 8 is now touching angle B, so this is my adjacent, not the opposite. So that's kind of flip-flops based on which angle we're focused on. So from angle B, sine is opposite over hypotenuse is going to be 15 over 17, which happens to equal that one. 15/17 sine A cos B. And other scenario from cos B is adjacent over hypotenuse is 8 to 17, which equals this one. And then last but not least, tangent from B is opposite over adjacent is 15 over 8. Now that's just the setups. And that's in order to find an angle. So again, that's just focused on the angle, identifying your opposite, your adjacent, and kind of just filling in these little fractions. How are those used? Those fractions are used to find a missing side. So exercise 3 is going to go like this. Set up a trig ratio to find a missing side. And we are going to round to the 10th place here. Okay. So these examples are going to, there we go. Sorry about that. Straightening this slant. So again, we're going to set up a trig ratio to find a missing side. When we have to round, we're going to round to the 10th place. So looking at this picture, what we're given in now is that this measure from here to here is 14. This side is what they're looking for to find x, and this angle measure is 38. In the past, we've been given a hypotenuse, a leg, and asked to find the other leg, and we've used Pythagorean theorem. But right now, we have an angle measure and two different sides. So what I'm going to write down is my little SOHCAHTOA, SOH, CAH, TOA. And some of you might prefer to write it like this. Some of you might prefer to write it the other way I had it a second ago. Looks like this, S, O over H, C, A over H, T, O over A. Doesn't matter to me how you write it, this version or this version. But I want you to remember that we have these fractions or ratios in there. So looking at sine, cosine, and tangent, what we do is a 3-step process. Step 1 is to label your O, your A, and your H, the opposite, the adjacent, the hypotenuse sides. Step 2 is to sub into the trig function. So again, it goes trig function, the angle equals maybe the O over the H, if we're using sine, or the A over the H, or whatever it might be. Then you cross multiply. Okay? So, starting with exercise A. We are focused on this angle of 38. That's the angle measure given. Then this side is your hypotenuse, which we don't have anything for. So we're not going to be using the H. Okay? So that means if I don't have the hypotenuse measurement, I'm not going to be using sine or cosine. It means I'm going to be forced to use tangent. So by labeling it, you're going to decide which one of the three trig functions you can use. Okay? The x over here is your opposite side, and your 14 is your adjacent side. So here we're going to use tangent of the angle equals the opposite over adjacent. And again, since I have the two values next to the opposite and adjacent, that kind of tells me we need the tangent function. So this is my general setup. So now we're going to do our substitution. So tan 38, the angle measure is 38, goes here. Okay. Before, we didn't have any measures next to those. Okay, down here, we were just looking at sine of A. We didn't have a measure next to angle A. So we couldn't put anything in for that. But now we do. We're given 38 degrees. Okay, equals the opposite, x, over the adjacent 14. So again, I've labeled my O, my A, my H. I've now substituted into my trig function, tangent of the angle measure equals opposite over adjacent. So notice there's three pieces, the angle measure and two different side measurements. Well, those are the three things in my picture, the 38, the x, and the 14. Now we cross multiply. So put this over 1. So when we cross multiply, we get x times 1, which I'm just going to leave as x, equals, now I like to put 14 first, 14 times tan 38. Now tan 38 is a digit, okay? If I go into my calculator, and again, I need to double check I'm in degree mode, and I just press tan and then 38, enter, it gives me a decimal, 0.78128. That's some irrational number. So think about this as like 14 times the square root of something. That's what we're multiplying together here. So at the beginning, I told you have to round to the tenths place, because tangent of 38 or cosine of 56 or sine of any angle measure, 72, okay, these are all angle measures that might be in your pictures. We have a 51, maybe it's cosine of 51, okay? Those are all irrational decimals that we don't have an exact value for. And there's a little trig table over here to kind of help you out, okay, if you flip back a page. So there we were finding tangent of 38. So tangent of 38 degrees is down here. Okay, is about 0.7813. Well, if I put that in again, tan 38, your calculator magically puts 0.7813. Okay, so these are all rounded to 4 decimal places for you if you don't have a graphing calculator. But what we're going to do is just type it in. Okay, this is multiplication. It's just like saying 14 times some radical measure, some irrational measurement. So 14 times tan 38 is 10.937. So here we're going to write our x. It approximates to 10.9379. And I do like us to write 4 decimals out first. Then we're going to round to where we need to. So here, this measurement is 10.9 as a final answer. Okay, that's what we were trying to find. How long it is for that segment. Now, does that make sense in the context of the question? It does. It's a little, we didn't know which one was longer or shorter, okay, but 10.9 and 14, now we could go and find the hypotenuse with the Pythagorean theorem. Letter B. I have a side, and an angle, okay? 2 sides and an angle measurement. What we have to notice here is we can't use Pythagorean theorem, but since it's a right triangle, this is where we go to trigonometry to help ourselves. So from that angle, we have the x and the 19. So this x is opposite, the 19 is your adjacent, and your hypotenuse would be down here. Again, there's nothing next to the hypotenuse, so we can't use h. So we decide which trig function to use. We're going to use tangent again, because we have the opposite measurement is an x value, would go in for the O, and the adjacent is 19, and our angle measure this time is 32 instead of 38 like the first question. So to set up our trig function, we're going to write tangent of 32 equals x over 19. I kind of wrote into my other work there, didn't I? Okay, let's get it. Step 3 was to cross. So tan 32 equals x over 19. So again, I decided it was tangent because I didn't have a hypotenuse measurement, so I can't use SOH or CAH because I don't have the H. So I decided on tangent. So tangent of my angle measure was 32, goes here. The opposite is x, the adjacent is 19. And we cross multiply. 1 times x is just x equals 19 times 32 is 19 times, tan 32. Again, tan 32 is some decimal value we don't know the exact value of. Okay, we don't need that right now. What I would put in is just this product. 19 times tan 32 equals, and that gives us 11.8725. So again, I like you to write down all decimal places. So x approximates to 11.8725, which would become 11.9 rounded to the nearest 10. So this side here is 11.9. So that's 2 questions. We're looking at letter C. First step is to label the O, the A, and the H, the opposite, the adjacent, and the hypotenuse. I'm actually going to skip D just because I kind of run out of some space here. But we're going to move on to exercise 4. So looking at this picture, we focus on the 51 degrees. Okay, so again, we decide what angle we're given. Okay, and we look at the 2 pieces they gave us. Okay, so this side that touches 51, we don't have. Right, that'd be our adjacent. So that means 14 is your opposite side. X is your hypotenuse. So opposite and hypotenuse. I have something to put in for the O and an H. So I have something to substitute in for O and H. So O and H is going to be our sine function. I'm going to box myself out so I don't run out of space. So we're going to put in sine of the angle equals our opposite over hypotenuse. So sin is how we abbreviate it. The angle is 51 equals the opposite side they gave me is 14. The hypotenuse I'm looking for is x. Now this is the confusing piece. When I cross multiply here, we get x times sin 51 cross multiplied in this direction equals 14. Now remember, sin 51 is some decimal value we don't have an exact answer for. So we need to get rid of that on each side so that x stands alone. So again, we're trying to solve to get x alone. That's the side we're looking for. So we're going to divide both sides by sin 51. So x equals 14 over sin 51. So into our calculator, 14 divided by sin 51. Okay. 18.014 equals 18.0146. Now, that measurement is going to be 18.0 rounded to your 10th place. That's the length of that hypotenuse. So moving on to two quick word problems. A ladder leans against a wall as shown in this diagram. So here we have a 4-meter ladder going up the side of a wall. It's a really bad sketch. Okay, and it makes a 68-degree angle at the ground. I'm only going to answer part A for now, just to keep this video short and sweet. How far is the top of the ladder from the ground? How far is the top of the ladder from the ground? So the top of the ladder to the ground is the side we're going to be looking for, X. So again, we decide what angle we're focused on. So when you're given an angle measure and two side measurements, that's your hint that you're going to need GeoR. Okay, so from our angle, the two sides we have to decide is it the opposite and hypotenuse, is the adjacent and hypotenuse, or is the opposite and the adjacent. So from X, we have the opposite side is X from 68, and they told you the ladder is the hypotenuse here, coming up the diagonal. So O and H means we're going to use the sine function, okay, not cosine or tangent. Here I don't have the adjacent side, so I couldn't substitute into there, and same thing with GeoR. So O and H means we're going to use sine. So the setup goes like this. Sine of the angle measure 68 equals the opposite measure, X, over the hypotenuse. Put that over 1, and we cross multiply. So X times 1 equals 4 times sine of 68. Times on 4 times sine of 68 is 3.78. Now, in my calculator, I'm just noticing sometimes I do put in the multiplication, but remember your calculator recognizes two things next door to each other are going to multiply. Just like we did 4 square roots of 2, okay? We don't put a multiply sign between those, but it's the same as 4 times the square root of 2, okay? So again, you don't need the multiply sign in between it, but as we're solving, it just helps to know that we're multiplying those two things. So again, X approximated to a decimal of 3.7087. So we're going to say approximately 3.7 meters is how tall this is. And that makes sense. It's a little bit shorter than our ladder measurement. So if you got something longer, like 8, you'd know you were wrong, because the hypotenuse should be the longest side there. Exercise 5, we're going to draw our own diagram. A ladder leaning against a building makes a 58-degree angle with the ground. So here's your building. Let's get a better ladder this time. Now, most buildings I know are built square to the ground. So that's what tells you that we have a right angle here down at the bottom. So the ladder leaning against the building makes an angle of 58 degrees with the ground. The distance from the foot of the ladder to the building is 6 feet. So from the foot of the building to the foot of the ladder, that is 6 feet. How far up the building will the ladder reach? Ooh, tongue twisters today. So how far up the building will it go? So again, your building is what's over here. So in that case, we have to know that this is trig. So we're thinking, Now, do I have anything next to my hypotenuse? Do I have any measurement of how long that ladder is? I do not. So we cannot substitute into anything with the hypotenuse. So from our 58-degree angle, this is your opposite side, X. The adjacent side is the foot of the ladder touches the 6-foot side. So we know we're going to use tangent. So tangent from your angle 58 equals X over 6. So again, you have 3 measurements kind of given to you, what you're finding, the angle measure, and one of the other sides. So you decide the trig function based on the position in the picture. The angle measure goes next to that, equals what we're looking for over what we're given. Cross multiply, x equals 6 times tan 58. Now again, I always put it this way because I put the digit first. So that single number by itself, 6 times tan 58. Because otherwise, notice when you press tan, it opens a parenthesis, 58. You can close it, you don't have to. But if you put in tan 58 times 6, it gives you two very different answers. Okay? So that's where I just get in the habit of putting the number first, times tan 58 second. We're looking for about 9.6 feet. So x approximates to about 9.6 feet. So that's it for our notes today. I say that's it. Some of you probably caught on right away. Some of you might need some help. I'm going to set some of these up with you. Here, it's going to tell you how many decimal places, 2 decimal places to the 10th, to the 10th, okay, and so on. So those rounding pieces are important. But remember, when we have to solve for a side, SOHCAHTOA, SOHCAHTOA. Also, we're going to put the measures in. So, exercise 1, triangle ABC, calculate AC to 2 decimal places. So what we're looking for is this side here, A to C. Given that angle B is 50 degrees. So from the angle you're focused on, you always have to label the O, the A, and the H in your picture. Step 2 is to decide if it's sin, cos, or tan. Right? And then we'll substitute and cross multiply. So from angle B, we know x is the opposite side. 3 is touching the 50 degrees, so that's going to be your adjacent side. And down here is your hypotenuse. Again, there's no measure next to the hypotenuse. I have an x and a 3 so far, the opposite and the adjacent. So this is going to be a tangent function because I have the O and the A. So the opposite is tangent. We put the angles next, 50 equals opposite over adjacent. Okay? And I'd like you to solve from there, okay, to 2 decimal places. So you got to do your cross product on your own. Looking at exercise 2 is very similar to exercise 1, so I'm not going to do that one with you. I'm going to just do a selected couple of these. I'm going to try number 3 with you. From that angle at R, we're looking for little r over here, which from that 25 degrees is your opposite side, R. And they do give you your hypotenuse. So opposite hypotenuse, so or TOA, since I have the hypotenuse and the opposite hypotenuse, we're going to use the sine function. So again, it goes sin, the angle measure of 25 goes next, equals r over 15. And you're going to cross multiply to solve for r. So r equals, and I'd like you to make sure you finish up that one. The only other question we haven't necessarily looked at, let's do number 10 together. I'm sorry, number 5 together with this 10.00 and the degree measure with the decimal. So I do want you to try all of these. There's 6 on the front and 5 more on the back. So you have 11 questions total. But here we want to find DF is the hypotenuse. This one's a little bit different because x is going to be in a denominator of our fractions. Okay, so I'm going to set this one up with you. 4 is pretty easy to do on your own, and 6, and if you're struggling with these, you need to shoot me an email. But looking here, find DF to the nearest tenth. So I put an x there. Again, since we're focused on this angle of 43.6, which decimals are okay, we have our opposite side and we have the hypotenuse. So opposite hypotenuse is the sine function, O and H. So we're going to have sin of my angle, 43.6, equals the opposite, 10. I'm just going to leave out the 0.0. I know it's 10. Over the hypotenuse x. So hypotenuse goes in your denominator. Okay. Now this is where some students get a little confuzzled, is when x is in the denominator, you're going to divide, is my little clue. X in the denominator, you're going to divide. So when we cross multiply, and I'll show you why we divide, x times this equals x times sin 43.6 equals 1 times 10 is 10. When we cross multiply those pieces, x isn't alone yet. So in order to get x alone, we have to divide both sides by sin 43.6, divide by sin 43.6. So therefore, x equals 10 divided by sine of 43.6, and then you're going to approximate to some decimal place. Okay, and that's like exercise C from over here. Okay, so I wanted to set up one more of those for you. One other question, sine from E. If you're focused on E, make sure you label your hypotenuse, your opposite, and your adjacent. So sine from E equals whatever the opposite side is over the hypotenuse. And we're just looking for that fraction is one of those 4 answers. Okay. Exercise 11 is going to be worth extra credit. If you have any questions on these or are really struggling, please email me to let me know.